Hey everyone, on this lesson we're going to introduce routing in IP networks. So given the index of IP networks, we are now at the lesson on routing. And so routing is essentially the manner or the way in which datagrams walk over the network. So here we can see we have a network structure, here we have a network, here we have another, right? And now, for instance, how does the PC1 know that PC2 or PC3 or PC4 or even PC5 exist, right? How can this PC1 transmit datagrams to them? Well, this is known as the routing table, okay? What is the routing table? This is a database that each router and host has. It contains the information necessary to reach all of the destinations. So now let's study and introduce the fields of a routing table. The first field we have is the field of acquisition. This indicates how an entry in the table has been acquired. Then we have the destination field, which indicates which are the destinations reachable by this device in terms of the IP addresses and mask. Now, destinations can be IP addresses, network addresses, or all destinations. We're going to see examples of this. Then we have the mask of this destination, as we know. We already introduced the mask before. Then we have the gateway. Now, this concept of gateway is very important. The gateway here indicates if to reach a destination, okay, it is necessary to go through a router, or if the destination is in the same network. So, if we have, for instance, to go from PC1 to PC4, of course, PC1 and PC4, they are not in the same network, right? PC1 is in this network 10.0.0.0, and PC4 at this one, 10.0.2.0. So the gateway is going to be here the information that we need to pass through the router R1. We are going to see examples of this, okay, in this structure that we have here on networks. Finally, we have the interface. So this merely indicates through which interface it is needed to transmit to reach the destination, right? Here we have the interface, for instance, E0, E0, E2, right? And we have here these interfaces. So now, once we introduce these fields of the table, of the routing table, each entry, each row in this table forms what is called a route to a destination. So it is essentially a route between source and destination that is determined as the sum of the next steps. That is, each element of this network determines only a part of the entire route. So, let's now study the first example. So here we have, first of all, okay, the PC1 routing table. So we are studying now the routing table of this host, of this computer, PC1. Here the acquisition is C. This is because this is a direct connection. So we configure in the IP address, okay, of this interface of PC1, this entry is created, okay. Here it says how to transmit to the destinations of this network, and this value of the acquisition is C because this is a direct connection. PC1 is connected to this network, and so therefore it can reach all destinations on this network. As we can see, PC1 is connected to this network in here, to this destination. Hence, we have an acquisition of C, right? So remember that the mask, here this mask, is the mask of this network. Keep in mind that this network has a mask of 24. Okay, what does that mean? Well, 24 means that we have 24 bits, okay, which are for the net ID. That's why here on the mask, we have here the first 24 bits. Remember, here we have this representation in decimal. So here we have 8 ones in binary. Here we have also 8 ones in binary, and here 8 ones in binary. So in total, if we sum, we have 24 bits in one, which is the net ID, right? We already know how to represent masks. Now the gateway is 0000 because here we have this network to be connected directly to this PC1, and this is in the interface that we are studying, right? E0. So whenever we see a gateway of 0000, this is indicating that it's not necessary to go through the router. The destinations are local. Now the interface E0 basically indicates that this interface code E0 must be used to transmit. Okay, so now the next step in this case is to send the datagram to the destination that is on the same network as the source. Now here, let's study a following example, another case. We are still inside the PC1 routing table, studying this same interface, right? Now, what if instead of going to this same network, we want to go to this one, 10.0.1.0. So this destination with a mask of 24, so we have here, precisely, we should have here the mask of the network. However, note, what are we wanting to go? We want to go, okay, to this PC3. So we don't want to go to this network, but we want to go to this PC, which is connected to this network. In fact, what we want to go now is to this destination, 10.0.1.10. So this PC3 is connected, okay, to this network. Now, this has an IP address of 10.0.1.10, okay? So how can we go from PC1, which has this IP address, to this PC3? How can we connect those two, right? So essentially, we need to go to this network. We need to pass this network because this PC3 is connected to this one. However, the destination is not the network. The destination is the PC, the host PC3, this computer. Therefore, we need to have here the mask for this IP address. Keep in mind that since this IP address, we take all of the bits, right? Because this is an IP address of a computer. Here we have the mask that they are all ones, right? They are all ones, as we can see here, because we have a host, right? Now, as we can see now, the acquisition is not C because this PC is not connected to this one. Okay, this is a static input, which is basically manually configured. We are going to configure this. And now, very, very important, what is the gateway now? Okay, what is the gateway here? Well, keep in mind, okay, the gateway, very important. The gateway is always, okay, the point of arrival to the router. So we want to go from PC1 to PC3, right? So the gateway is, if we keep going, if we just follow this pointer, we keep going, we reach the router. So now the IP address of the interface where we reach the router, not where we live, where we reach, is this. So this is the gateway. So we can even draw this to facilitate this comprehension. So this is essentially what is happening, right? We have the PC1, it is connected to this network. Then we have PC3, which is connected to this one, and I want to send a message, right? I want to send a datagram to this destination in here. So what is going to be the gateway? Well, if I have this interface of this IP and this interface with this IP, the gateway is the A. This is the gateway. The gateway is not B, because here many people, okay, have the mistake of basically saying, okay, I have to send the message to PC3, I go through this router and I live with this, so this is the gateway. No, this is not the gateway. The gateway is where we reach the router. So if I need to go to this PC3, I reach the router with the A, so the gateway is A. So if I want to go here, okay, the fundamental, from PC1 to PC3, the gateway, okay, the gateway is A. However, if I want to go from PC3 to PC1, so now I need to do the reverse datagram sending. So now my destination is PC1, right? Now we reach the router with B, therefore now the gateway, okay, in this destination is B, right? So very important, this fundamental of the gateways. Right, so here as we can see, we go from PC1 to PC3, the gateway is this one, right? 10.0.0.1, that's what we have here, 10.0.0.1, right? We have to go through this interface to reach the destination. Now the next status in the diagram is basically to pass the datagram to this router by transmitting out the interface E0 to reach this host, PC3. Very well, now let's study another case. What if now we want to send a datagram, okay, and the destination is this network. So now the destination is not a host, the destination is the network, which is this one, right? 10.0.2.0. So since this is a network, of course, the mask is going to have the number of bits of this network. So it is a mask of 24 bits. That's why we here see the first three decimal values to be 255. Remember, whenever we have a decimal value of 255, it's like if we have 8 ones in binary, right? So we have 8 ones plus 8 ones plus 8, 24 ones in total, right? This is the number of bits of the net ID. Now, I want to go from PC1 to this network. So I need to go this path, right? We need to follow this path. And once again, the gateway is the same, because if I need to go to this network, I need to pass through the router R1, and following this path, the way that I arrive is the gateway, and I arrive with this interface. I reach the router with 10.0.0.1. That's why here the gateway is the same. Once we have this entry in the table, again, this is the static input because we manually configured this entry. So the next step is to pass the datagram to this router that we have here, to this interface, transmitting through the interface 0 to be able to reach any IP address of this network that we want to have as the destination. Now, in the routing table, whenever we have the destination to be 0000, this here represents any destination. Okay? Whenever we have this destination, the mask will also be 0000, indicating any mask. And usually this destination 000 is used to indicate the internet. And so if we go from PC1 and I want to go to any destination, the only way that we can go is through this router R1. So we need to pass through this interface, right? So the gateway is going to be again 10.0.0.0.1. So suppose here, after we have here an internet or a very biggest here network, we'll always have to pass through this gateway. Okay, very well. So once we have introduced the routing table for this host, for PC1, for this computer, now what about the routing table of the router R1, for instance? So routers also have routing tables. So here we can see the routing table of R1 for all of the networks that he can reach from. So we begin, okay, of the network 10.0.0.0, right? So why is the acquisition C? Well, because this acquisition is a direct connection. R1 is directly connected to this network 10.0.0.0. Therefore, this acquisition is C. The mask is, of course, here 24 bits of the net ID. That's why here we have the mask. And so now the gateway here, remember, when the gateway was 0000, okay, this indicates that it's not necessary to go through a router. The destinations are local. And this is, of course, what is happening in this case, because from the router R1, we can go directly to this network. The same happens with this network above, 10.0.1.0. Here we can see the gateway is 0000. We don't need to pass any other router. And finally, we have 10.0.2.0, which is the gateway also 0000, because R1 is directly connected to this network. Now, finally, the network 10.0.3.0. Well, in this case, since this direction is not a direct connection, it needs to be manually configured. That's why the acquisition is static entry. This is static because it is manually configured. And also, okay, the gateway, okay, that we need to go to reach this network is we go from the router R1. So if we follow this path, we can see that as we enter the router R2, to be able to go and here arrive to the network 10.0.3.0, we need to go through this interface 10.0.2.2. So we arrive to the router, we reach the router, okay, on this IP address, on this interface. That's why this is the gateway, because it is always the IP address that we reach in the router, right? So we reach this router to go to this network. This is the gateway, as we can see. And finally, to reach this piece, or in this case to this network, we need to go from the router R1 through this interface, right? E2. That's why here the interface is E2. Very well. So this is on the networks. All we have here, these entries represent the network. So we can also add the destination for a host. Imagine that we want to go to this host here, right? The host 10.0.3.30. Well, if we want to go to this host, PC5, the destination is this IP address of this host, of this PC5. The mask is now all of the bits because it is a host ID, or in this case, the host address, not the host ID, but the host address. And always when the destination is a host, when the destination is a PC, the mask is always full, okay? It's always complete mask. The gateway is again this one because we need to pass through the router R2, and we reach the router R2. We arrive to R2 through this IP here of the gateway. So this is the gateway, right? Again, the interface is E2, okay, because we need to pass here through this interface E2. And the same happened in that case of this network 10.0.2.0. To go to this network, we need to go through E2, right? Okay, so with this we introduce the fields of the routing tables. We know the acquisition, the destination, the mask, the gateway, and the interface. Very important here not to confuse the gateway with the interface. They are two different things. The gateway is if we want to reach a destination, is the gateway of the router that we pass to reach this destination. So we arrive, for instance, to this destination of this network in here. We arrive to this router R2 and we arrive to this IP address, so this is the gateway. However, the interface is the interface of our own router, so of the source router here, right? So the source router is R1 and the interface is E2. The gateway is the destination router that we need to pass to go to this PC5. Of course, if we have more routers, imagine that we don't need to pass only one router but more. We will see more examples of this of the gateway. So this is only the first introduction. We'll see many more examples to define these entries for the gateways and these tables. So with this, we end this introduction on routing. On the following lesson, we'll continue to study IP routing and we will learn the longest match lookup principle.